Hello, welcome to lesson 3, video 5 for our stoichiometry unit for chemistry 1. In this video, we're going to learn the last type of conversion for stoichiometry, and that is a mass-to-mass 3-step conversion. So in this one, we're going to be starting with grams. We're going to be converting to moles, and by doing that, we're going to use our formula mass, and then we're going to go from moles of one thing to moles of another using our mole ratio. And then we're going to go back to grams of something new using formula mass. So that is where we get our 3 steps. So in all of these, we've always started with what is new and what is given and what we want. So if we look at our problem, it says how many grams of ferric sulfide can be made from 45.25 grams of sulfur and excess iron. You are always going to be given an equation. So I'm just going to write out our equation here. And then we can go ahead and balance this one. And this one's pretty easy to balance. So this is the now balanced equation. So if we interpret what the word problem is asking, we're going to underline what we're given. So we're given 45.25 grams of sulfur, and we're looking for grams of ferric sulfide. So that would be this substance here. So as always, we're going to start with the number that we're given in the problem, 45.25 grams of sulfur. I'm going to make our chart a little bit long here because we have a lot of things to write down since we had 3 conversions. So if we look at our little hint guide or this little guide up here, we're going to start with grams and we're going to go to moles. So we need the formula mass, well in this case since we have an element, the atomic mass of sulfur. And if we look that up on the periodic table, we see that it's 32.07 grams. So we have grams of sulfur here, so we're going to put the 32.07 grams of sulfur in the bottom so our units cross out. And as always with formula mass, it's always paired with 1 mole of that substance to make us a true statement or a statement that equals 1, because 1 mole of sulfur is 32.07 grams. Now that we have got rid of grams, now we want to get rid of moles of sulfur because we want to go to ferric sulfide. So in order to go from moles of one thing, we can go to moles of another using the coefficients in our balanced chemical equation. We want to get rid of moles of sulfur and go to moles of ferric sulfide. So 3 moles of sulfur create 1 mole of ferric sulfide. So I'm going to put the 3 moles of sulfur in the bottom so our units cross out, and I'm going to put the 1 mole of Fe2S3 ferric sulfide on top. So now if I stopped here, our answer would be in moles of Fe2S3. I want grams, so I know I'm going to have to use the formula mass again, but this time for Fe2S3. So we have to calculate that. So we have 2 Fe's and 3 S's. Fe was 55.85, and sulfur we already looked up, 32.07. So when we multiply those and add them together, we get 207.91 grams. And we know that that's how many grams there are in 1 mole. We want moles to cross off, so I'm going to put the 1 mole of Fe2S3 on the bottom. Now on top, I'm going to put the 207.91 grams of Fe2S3. Now my moles cross off, and I'm left with what we're looking for, grams of ferric sulfide. So in your calculator, you really want to make sure that you are putting things in the calculator correctly, because you can have an order of operation mistakes if you don't hit equals after everything. Remember, if something's in the top, you multiply. If something's in the bottom, you divide. So I'm going to take the 45.25 divided by 32.07 and hit equals. I have a 1 in the top, so I don't have to do anything there, but I have a 3 in the bottom. So I'm going to hit divide by 3 and hit equals. And then I had the 207.91 in the top, so I'm going to multiply. So multiply by 207.91 and hit equals. Now, as you can see, I get 97.78533,936. That's way too big. So we have to write this to significant figures. So this beginning number has 4. This one has 4. And our other formula mass has 5. So 4 is the least number of significant figures. So I'm going to round this one. So 97.7, and then 8 would be our last significant figure, but that 5 bumps that up to a 9. So we end up with 97.79 grams of Fe2S3. Don't forget to put a unit and a label at the end. Every single mass-to-mass problem is set up the same way, so we can write a general form. So we always start with the mass given in problem. Then we're going to have the formula mass of the given and 1 mole of the given. Down here, we're going to have the moles, which is the coefficient of the given. And up here, we're going to have moles, or the coefficient from the wanted. In the bottom, we're going to have 1 mole of the wanted. And up here, the formula mass of the wanted. And that will give us grams of the wanted. So we're not going to do these problems down here. So on Schoology, I have an additional page of example problems for you to look at. And then there is a worksheet that goes with mass-to-mass stoichiometry problems. This will be the last video and last lesson for this unit.